In this video, I'll show you how to generate high-resolution digital surface models, orthophotos, dense point clouds, and photorealistic 3D elevation models from UAV data in ArcGIS Pro. You will need ArcGIS Reality Mapping license for this, so let's get started. Launch ArcGIS Pro and create a new map project. Navigate to the folder where you want the project to be stored. To speed up processing speed, let's modify the environment settings. On the Analysis tab, click Environment and locate the parallel processing parameter in the Environment dialog. It is 50 by default, so you want to change that to higher number, maybe 90 or 80 as you want. Now, let's create a reality mapping workspace. On the Imagery tab, in the Reality Mapping group, click the New Workspace drop-down menu and choose New Workspace. In the Workspace configuration window, type a name for the workspace. Ensure that workspace type is set to reality mapping. The sensor data type is drone and the scenario is default. Accept all other default values and click Next. In the Image Collection window, click Add and browse to the data location to select the image folders. The photos will be added to the dialog window. Ensure that the spatial reference and camera model values are correct. If not, modify by clicking the spatial reference button and choose the correct reference system for your project. Click Next, accept all the default settings in the Data Loader Options window and click Finish. You will see a reality mapping container added to the catalog where the source imagery data and the derived mapping product will be stored. All layers relating to the reality mapping project are added to the content pane. You'll see the data product, which for now contains no files or layers. The source data there, which has the boundary, the footprint, and the image. The images, drone paths, and image footprints are displayed on the map. You can zoom in to see some of the images loaded. You might not see all your images loaded in the map view due to the mosaic data set format that S3 uses, but that's okay. You are good to move to the next step, which is block adjustment. The block adjustment first calculates tie points, which are common points in areas of image overlap. The tie points are then used to calculate the orientation of each image, known as exterior orientation in photogrammetry, as well as locations of the 3D points. So on the Reality Mapping tab, in the Adjustment group, click Adjust. In the Adjust window, under Block Adjustment, uncheck Quick Adjust at Coarse Resolution only to make adjustment more robust. If you want a quick solution, you can check this. Check the camera calibration options to calculate the lens distortion parameters during adjustment. You can uncheck these options for high quality camera with known calibration. Blunder point threshold set the error limit for point to be used in computing the adjustment. Set this to 5 or as desired. Check the use orientations from metadata. This reduces the adjustment duration using the exterior orientation information that is embedded in the images EXIF as initial files. Tie point matching defines the resolution at which tie points are calculated. Larger values allow the adjustment to run more quickly. For image location accuracy, choose I from the drop-down menu. Click Run. The block adjustment will take a bit of time to finish. So let's come back to that when it is completed. Now the process is completed. The logs display statistical information such as the mean reprojection error, which signifies the accuracy of the adjustment. There is also the number of images processed, the number of tie points generated. In our case, we have more than 600,000 tie points. The whole process took about 15 minutes. At this point, the relative accuracy of the images has been improved and we can generate products. But before that, we need to also improve the absolute accuracy. To do this, ground control points must be added to the blocks. So let's do that. Go to the Reality Mapping tabs and click Manage GCPs in the Refine group. The GCP Manager window should appear. So in the GCP Manager window, click Import GCPs buttons. The Import GCP window opens. Browse to the folder where you save the GCP file and select. Click OK. Under Set GCP Spatial Reference, click the little globe button and set the spatial reference of your GCPs accordingly. Click OK. If you want to transform your reference system, you can do that under Geographic Transformation section. So map the GCP fields accordingly. Put the X to be X, the Y to be Y, and the label to be label. Click OK to import the GCPs. The imported GCPs are listed in the GCP Manager window. Now let's add tie points to the GCPs. Click each GCPs in the GCP Manager window. A small window below will show images containing the GCP you selected. The photos are listed according to the ease of locating the GCPs. So the first are almost always the easiest to use. Click the Add GCP or Tie Point button in the GCP Manager window and add a tie point. The tie point for other images are automatically calculated by the image matching algorithm when possible. So images that have tie points will be marked by blue cross next to the image ID. Review each point for accuracy. So check each image and make sure that the tie points are accurately located on the image. If the tie point is not automatically identified or in correct position, you have to do it manually by selecting the appropriate location in the image. After each GCP has been added and measured with tie points, select one of the GCPs and change it to a checkpoint. This provides a measure of the absolute accuracy of the adjustment, because checkpoints are not used in the adjustment process. After adding GCPs and checkpoints, click Adjust to run the adjustment again in order to incorporate this point. It will take a while to finish the adjustment also again. So I will come back after a few minutes. After completing adjustment with GCPs, 3 new fields, the X, the Y, and the Z, are added to the GCP Manager table, and they display the residuals for each GCPs. The root mean square error of the residuals can also be viewed by expanding the residual window. Additional adjustment statistics are provided in the adjustment report. Once the block adjustment is complete, 2D and 3D image product can be generated using the tools in the product group on the reality mapping tab. We can use multiple products option to generate all products, or we use individual name products like DSM only, true orthophotos, DSM mesh, point cloud, or 3D mesh. Let's do the multiple product option. Click the multiple product button in the product group. The reality mapping product wizard windows appears. Uncheck any product that you don't want. We'll leave everything checked for this processing. Click the shared advanced settings button. The advanced product settings dialog box appears, where you can define parameters that will impact the reality mapping product to be generated. The quality and scenario values are automatically set and should not be changed to ensure optimal performance and product quality. Accept the pixel size default settings to generate product at source image resolution. Check the apply global color balancing and also enhance true orthophotos texture checkboxes. This will apply color correction to the true orthophoto and mesh product. So accept all the other default values and click OK. Click Next to go to the DSM settings pane. Change the output type to mosaic and format to TIFF. You can use cloud raster format too. Leave other settings as default. Click Next to go to the true orthophoto settings pane. Use same parameters as set for DSMs. Click Next to go to the DSM mesh settings pane. Change format to SLPK and texture to JPG and DDS. Click Finish to start the product generation process. It will take a while for the product generation to complete. Once the product generation has been completed, the DSM, the true orthophotos are added to the 2D map view. They are also added to the content pane and to the appropriate folder in the reality mapping container of the catalog pane. In the catalog pane, under the reality mapping container, the DSM mesh products are added to the meshes folder. Point cloud are also generated and added to point cloud folder. To visualize the generated DSM mesh products, right-click the file and from the drop-down menu, click Add to New and then select Local Scene. Explore your models and boom, you're done. Reality mapping is very straightforward in ArcGIS Pro.